Vamos. You know, there's a file which is circulating just to show you some examples of the data sets that we are manipulating coming out of the dendrometers. But just to tell you the context in which this data set is coming is just here the case, what we show a case study about the study of heterosis in larynx. So I told you that the hybrid between European and Japanese larch usually have an overexpression of growth, which is called heterosis. We showed through different studies that it has a genetic but also an environmental determinism. And the level of heterosis can change according to space and time and also the genetic background, because it depends which population you are crossing and And what we observe also is this level of heterosis is variable according to the traits. For example, for growth, you have heterosis. For wood density, this is just in between the parents. For chemical extractives, it looks like it's a bit like growth, it's overexpressed. So many traits, many different situations. This is just to tell you, well, what else? Yes. It's what I mentioned yesterday, you know, that when you talk of biomass, biomass is something which is global and which is made up of height and diameter. And height and diameter is already a complex trait. And the idea here is to go down to different components of height. That means in annular increment, in diameter, in annular rings. And then annular rings, you can split it in initial wood and final wood. And then you can go down to the Howry increments, for example, and get access to more phenological data and growth rhythm data, just than going to a biomass. Biomass is so complex that So, and what we are studying is basically what are the level of variations in phenology and growth rhythm among the taxa. We want also to look at the relationship of these performances with climatic factors, and also we are interested in trade-off between traits. So, for example, if you think that the hybrid is growing much faster, sometimes it's 2 200% faster than the pure parents. So you might think that maybe there are some other traits for which you will lose something. So, for example, in wood properties or in adaptation or whatsoever. So we try to figure out, you know, if this faster growth is detrimental to other traits of interest.
Claro, eso lo que dice, él plantea que el híbrido crece hasta 100% más que los padres, pero él quiere entender qué pierde con tanto crecimiento o en ese sentido es el trade-off, este balance. Porque, ¿qué pasa con las características, con la calidad de madera, con ese tipo de cosas que a lo mejor que él quiere evaluar? ¿Qué va en detrimento, o sea, qué es lo negativo de ese mayor crecimiento, digamos?
Okay, and this is something that Maria-Elena just told you. When you want to study hybrid vigor, you need some dedicated mating plans. When you will be combining the same genotypes of the parents together, so to get pure European large, for example, in this case, pure Japanese large in that case, and then you got the hybrid.
Fíjense que los primeros, desde el 104 al 234, son europeos, son europeos. Después, del 3179 al 3217 son japoneses. Fíjense que él cruzó entre los europeos, lo mismo para la parte, digamos, de arriba. Él cruzó entre los europeos, cruzó usando el japonés como madre y el europeo como padre en el segundo cuadrante. Después, en el tercer cuadrante, tiene híbridos usando el europeo como madre y el japonés como padre, y en el cuarto cuadrante tiene, o sea, japonés por japonés.
So
tiene como todas las combinaciones posibles.
So it's very important to get this kind of design to really compare the hybrids with something which is related genetically.
Claro, desde el punto de vista genético es muy importante tener ese tipo de cruzamiento para verdaderamente probar la superioridad de los híbridos respecto de los padres. Es una cuestión genética esto, o sea, por eso yo lo miro y a mí pues, se me cae la baba, digamos, porque ojalá nosotros podemos tener eso. Pero pues, no hay muchos casos en el mundo de híbridos que tengan un diseño así. Pero bueno, es lo que hay.
So, and the trees, the seedlings out of these mating plants were planted in different sites across France. But the problem is that when you have a first site, so you cannot go every day because sometimes it's 300 or 400 kilometers far apart. So you can only make some punctual measurements once a year or once every 5 years, and you cannot monitor on a regular basis the growing of your trees. So we decided, in order to get more insight into heterosis, to make a subset of this diagonal mating design, which is represented by the gray cells, and to establish it in a new sites in our institute.
Claro, decidió replicar a través de injertos algunos de esos cruzamientos, digamos, para tenerlos más cerca y poder estudiarlos más de cerca.
So we have 3 different species. We have 12 full SIP families per species. We have 9 to 13 individuals per families, and we have 2 to 3 ramets per clone.
Claro, tiene 2 o 3 rametos por cada clon de entre 9 y 13 individuos que pertenecen a 12 familias, bueno, y que tienen mezclado de las 3 especies. O sea,
And so this is the kind of trial that we have. We have one in Orléans, so that we can go every day if we want. And so we had two treatments, one which is continuously irrigated, it's drop irrigated, and one which is not irrigated. And this is a bit like all the trees look like, you know, according to the treatment. And then we have one, which is this one, which is this is not at all typical for plantation of larch, but this is more a typical site for planting larch in France.
Ese sitio está Orleans, ese irrigado y no irrigado, que no es un sitio típico para Lares. Y en Beaumont-du-Lac, es otro sitio que está más al sur, pero que es más típico para la especie, digamos. Entonces ahí también tiene una réplica.
Yeah. Typically here we get 600 millimeters per year. In that case we go up to 1,200 or something like that. So, yeah.
Orleans está a 600 milímetros por año, tiene 600 milímetros por año y un suelo más arenoso, digamos. Y Beaumont-du-Lac está a 1.200 milímetros por año. Tiene mucho más precipitaciones.
So we wanted to contrast, you know, the water stress in the different situations. So you have the irrigated one, where you see that the water deficit is nearly has disappeared because of the water upload that we are doing, compared to the non-irrigated site where you have very strong summer water deficit periods. And you have in Beaumont, you can also find some periods during the summer with some water deficits.
Él tiene los mismos materiales en diferentes situaciones. Y fíjense que en la parte irrigada de Orleans no tuvo casi déficit de agua, digamos, o tuvo disponibilidad de agua durante 2016 y 2017. Mientras que la parte que no estaba irrigada tuvo fuertes déficits hídricos y en Beaumont-du-Lac en el año 2016 y 2017 también tuvo fuertes periodos con déficit hídricos.
Yeah. So the idea was to have contrasted sites for water in order to look how heterosis is showing up according to the water level.
Claro, él quiere ver cómo la heterosis o la superioridad de comportamiento del híbrido responde en esos tres diferentes ambientes.
So to monitor these trees, so we established 60 dendrometers on the irrigated and 60 on the non-irrigated sites, exactly on the same clones in both sites.
Claro, exactamente los mismos clones en irrigados y no irrigados.
Yeah, and in Beaumont we don't have irrigation, so it's natural rain. So we also established 80 dendrometers. So we have also soil humidity and temperature probes at different levels in the ground, in the different species plots. And meteor station, of course, to monitor very closely, you know, what's going on. And then we are making a lot of measurements on those trees in terms of phenology, growth, architecture, vulnerability to cavitation. We try to look of impact of different climatic events, fructification. So we try to accumulate as many traits as possible, you know, to look up at this trade-off between these traits. So this is what we have been doing so far, and we are doing that regularly. What we are thinking now is to go with microcores to monitor xylogenesis because the trees are getting bigger. Some increment cores that we might need also to look at, and the bank fitness, which might be useful as covariates in some other studies. So this is just to show you some results very quickly of what we get. So for example, this is the level of the hybrid, which is represented here on one of the forest sites. And you have the level of the European larch compared to the hybrid and the Japanese larch compared to the hybrid. So you see that the hybrid is really above the European and the Japanese larch on an average. This is the average performances of all the hybrids compared to all the European and Japanese larches. And we had a PhD student who worked on this, and he also wanted to take advantage of increment course data to make reaction norms according to the water availability, and again at a mean species level. So you have for the different species the way the species are responding to this water availability. And for example, you see that when water is very limiting, so the hybrids, there's nearly no difference between the hybrid and the parents. But the more the water is getting available, the more you get differences between species. So, and this is something which looks like the curves that you might see, for example. And this is typically what we mentioned this morning. We want to dissect, you know, this radial growth, between radial growth and water relationship properties, and look at variation between species, families, and clones, and relate that to climatic data. So we have not yet started to do the analysis, but you can already observe some few things. For example, I put here the maximum temperature, minimum temperature, and then you have the rainfalls, which are represented here, and you have the curves, some of the curves. And you see, for example, in May 2017, so we got a period of frost in May, and you can already observe that there's a kind of small plateaus connected to the damages, you know, linked to the damage of the foliage by the frost. And for example, we also get a very dry period during the faster period of the growth. And again, you can observe that quite quickly the trees are reacting by contracting. Okay, so that's just to tell you that the data sets that you have is just a subset of the data. And what we would like you to do is to look at this data set. This is something that I receive, you know, from the machine. And just to show you that even if it's automatic, if it looks nice and perfect and whatsoever, there are a lot of trouble that you can encounter. And I would like you to look a bit carefully at this data and just to try to find out some of these problems. Yeah.
Del dataset, digamos, completo, y que a mí me gustaría que ustedes miren el archivo, porque hablamos siempre de automático y parece todo perfecto, pero que hay verdaderos problemas en los datos, que si ustedes pueden mirar un rato
that means, as I said yesterday, that it needs to be checked really regularly, and you need to have very dedicated technicians to take care of that.
Dice que necesitan realmente chequear regularmente y tener técnicos muy dedicados al trabajo, digamos, porque es un problema.
Because typically in this study, you see that I have couples of clones, so I have couple of ramets in irrigated and non-irrigated. That means that if one dendrometer is not working very well, that means that the whole couple is lost. So if you open the file, so you can recognize, so as I mentioned yesterday, how would look like this data to be used by dendrometer. So you have a first column, which is the time. Then we have a second column, which is the record number. You have a third column, which represents the level of the battery in volts. And this allows you to check sometimes if the battery gets very low, maybe you start to get some problems. The fourth column is temperature, which is recorded at the same time. And then from D1, we have D2, D3, D4, and so on. These are different dendrometers. And they are recording things in millivolts. Maria-Léna, tu dois me dire quand on doit arrêter pour que, voilà.
Mais peut-être si tu as le fichier ici,
oui,
tu
peux le montrer.
peux indiquer plus ou moins parce que
oui, c'est difficile. Hein.
Oui, c'est difficile.
Voilà. Alors, attends.